Cadets and faculty at the United States Air Force Academy and the University of Colorado at Colorado Springs have designed, built, tested, and integrated their own small satellite. It was launched from Cape Canaveral, Florida on October 24th as a secondary payload aboard an Atlas IIA launch vehicle. Falcon Gold is named for the Air Force Academy mascot, the Falcon, and one of the UCCS school colors, gold. Academy staff and cadets have worked jointly with the University of Colorado at Colorado Springs and Lockheed Martin on the Falcon Gold mission. The objective of the mission was to characterize the global positioning system signal for use in orbit determination at altitudes above the GPS constellation. Falcon Gold relayed GPS signal measurements for 15 days after launch until the onboard batteries expired. The GPS measurements and health and status data were received at ground stations in Boulder, Colorado, and the United States Naval Academy in Annapolis, Maryland. Cadets were involved in the Falcon Gold project from its very beginning. Building satellites is a multidisciplinary problem which requires the talents and expertise of cadets and faculty members from many technical disciplines, including electrical engineering, chemistry, computer science, engineering mechanics, astronautics, and physics. Cadets were involved with each portion of the project, including design, fabrication, testing, integration, launch, and on-orbit operations. The Falcon Gold spacecraft contains 6 main subsystems: structure, power, communications, command and control, GPS, and thermal control. Cadets and faculty work together designing, building, and integrating each subsystem. In April 1997, the first Falcon Gold prototype was launched on a high-altitude research balloon to test the entire system.
In order to do an end-to-end functional test on Falcon Gold, we flew it on a high-altitude balloon to 105,000 feet. And this test allowed us to check our communication system. We received health and status data, which consisted of temperature data, voltage data, as well as GPS data. This was very motivational for cadets in the class of 1997 because it allowed us to see the fruits of our labor before the end of the year.
Throughout the Falcon Gold mission design and construction, cadets specialized in one of the 6 main subsystems. For example, the communications subsystem.
Our communications subsystem consisted of a terminal node controller which took the digital ones and zeros from the computer and turned them into 2 different frequencies. These 2 different frequencies were then sent to our transmitter, which modulated them on our carrier frequency. Our carrier frequency was then sent to our directional discontinuity ring radiator and transmitted down to our ground station.
Falcon Gold underwent vibration, thermal, electromagnetic, and explosion tests throughout the summer of 1997. All tests were successfully completed, but the vibration test demonstrated that some design changes needed to be made. The structure was strengthened with brackets on the side to prevent this from happening on launch. Falcon Gold was delivered to Cape Canaveral on October 13th for final launch vehicle integration. Approximately 4 hours before launch on October 24th, members of the Falcon Gold team watched as the mobile service tower rolled back, revealing the Atlas IIA Centaur rocket in flight configuration. The 79-minute launch window opened at 7:37 p.m. Eastern Standard Time, but the Atlas liftoff was delayed until 8:46 p.m., leaving only 10 minutes to spare at the end of the window. This delay, which was due to cloud conditions and an unsecured fuel valve, added both tension and excitement to the pre-launch atmosphere.
TV control, go. Operations Safety Manager, go. Range weather and final clear to launch, go. Payload test conductor, go. Launch director, go. Minus 45. Status check propellants. Go Atlas. Go Centaur. Go Centaur.
T-minus 10, 9, 8, 7, 6, 5, 4, 3. Atlas engine ignition, 1, 0, and liftoff of the Lockheed Martin Atlas rocket with a Discus 3 spacecraft for the United States Air Force on board.
Unfortunately, due to the effects of a major Colorado blizzard, the primary ground station in Boulder, Colorado was not operational for several days following the launch. However, within 2 days of the launch, personnel at the Naval Academy ground station were receiving data from Falcon Gold. For a total of 15 days, Falcon Gold transmitted GPS measurements and health and status data. On the 15th day, Falcon Gold's onboard batteries expired and the mission came to a close. The GPS data Falcon Gold gathered indicates that it will be possible for future spacecraft to navigate using GPS signals at altitudes above the GPS satellites. Agencies interested in this data include the Department of Defense, the National Reconnaissance Office, and civilian spacecraft manufacturers. In addition to gathering useful scientific data, Falcon Gold's flight space-qualified components for use on the next Air Force Academy small satellite, FalconSat. FalconSat is scheduled to launch in the fall of 1999 aboard a converted Minuteman missile.